Welcome everyone to Linux Minute channel. Hit the like button right away, guys. And even if you watch it first, all right, it's gonna be awesome. If you're not a subscriber, please ensure that you do that now. All right, so we'll be looking at CSEC, and we specifically looking at matrices. What aspect of matrices? What's a singular matrix? So let us just do some little background check on what is a matrix. So a matrix is cut up in rows and columns. So it's defined by rows and column. All right. So rows run from left to right. So this would be a row. So this would be two rows, and column up and down. All right. So these would be the two columns. So this is what we call a 2 by 2 matrix because it has two rows and it has two columns. All right. So let's get right into it. Now, a singular matrix is when the determinant is equal to 0. But what is the determinant? So every matrix is in this form: A, B, C, D. Now, when we multiply the leading diagonal, so that's AD, subtract the next diagonal, which is BC, if the answer is equal to 0, then it is considered to be a singular matrix. If it's not a singular matrix, it's called non-singular. All right. So let's get right into it. So it says, if N is a singular matrix, and they gave us 4, 2, 3K, find the value of K. So K is such that whatever K is, when you multiply 4 times whatever number and subtract 2 times 3, the answer must equal to 0, right? Because they told us it is a singular matrix. All right, so let's use this space as our little working area. All right, so remember it's in the form A, B, C, D, and the singular matrix is AD minus BC, and the answer is equal to 0. All right, so let's get right into it. All right, so as you say, it's AD, so it's 4 times K. K represents a number, right? Minus the next diagonal, which is 2 times 3. So that gives us 4K minus 6, and that must equal to 0. So all we have to do now is basically solve for the value of K, and that would be our answer. Very easy. So let us transpose. This is a minus 6. So we subtract 6 from both sides. So it will be 0 plus 6. So that's 4K is equal to 6. All right, so to solve the value of K, we divide by 4. What you do to one side, we do to the next side. All right, so we have K by itself. So our answer would be, can reduce this to 3 over 2, which is the same thing as 1.5. So the value of K would be 1.5. If we should multiply 4 times 1.5, the value is 6. And minus 2 times 3, which is also 6. So our answer would be 0. All right. And I've done this one on my channel before, but nevertheless, I'm going to do it. You guys want to pause the video and try it? Hit the like button if you're just joining. If you're not a subscriber, please ensure that you do that now. All right, let's go. So this Z is also a singular matrix. First, it says write down the determinant of Z. And then it says calculate the values of P for which make the matrix Z singular. All right, so let's get right into it. As I said before, I've done this on my channel before. I'm gonna go over it again. All right, you guys can always watch the playback. And ensure that you like the video in the meantime, guys, if you're not done so. Guys, why is it so hard to just like the video? That's all you have to do, all right? So the determinant is defined as AD, just put the number there, AD minus BC, all right? So let's go now. So it's 3 times P cubed minus 5P times 15. So this will be the first part, which is A. So that's the determinant, right? Let's just kind of simplify it. So it's 3P, 3 minus 5 times 15. That's what? 5, 5, 25. 5 ones 5, and that's 75P. All right. So we can say this is the determinant. All right. It says now for B, it says calculate the values of P for which the matrix Z is a singular. So if it's a singular matrix, the determinant is equal to 0. So since we calculated the determinant already, so it would be 3P 3 minus 75P. But guess what? Because it's singular, it must equal to 0. So let's just make it equal to 0. We are going to approach this now. All right, what I would have done is to factor out the common. So 3 is common. 3 can go into 75, and P is also common. So I'm going to take out 3P. So this would leave P squared minus 3 into 75. That goes 25 times, right? And that is equal to 0. All right, so there's so many options here. We can factorize right here, which is P squared minus 25. That's the same as this. Difference of 2 squares, so it will be P plus 5 and P minus 5. And remember, guys, all of this is equal to 0. So all we have to do is just take them 1, 1. When 3P equals 0, P is equal to 0 divided by 3, which is also 0. So the first one is P equal 0. And for the next one now, we're going to take when P plus 5 is equal to 0, P is equal to minus 5. So that's another option that can make it be a singular matrix when P equal negative 5. And also when P minus 5 equals 0, P is equal to positive 5. So basically, you have 3 options that can make it be a singular matrix. P equals 0, P equal 5, and P equal negative 5. All right. All right, let's go down to 3. What the hell? Why am I so speedy? All right, so 3. So this was 2. Very nice question, though. Big up yourself, CSEC. These are all past paper. Hit the like button if you're just joining. If you're not a subscriber, please ensure you subscribe now. It says, given that M is equal to 3B1A, calculate A, the determinant. As we said, the determinant is just AD, so that's 3A minus B. That's the determinant, all right? So this would be A. 1 times B is going to be B, and remember, minus is a part of the formula. So that is A, and B says a pair of values of A and B such that M is singular. All right, basically, we could just say, all right, I think 0 would be an option. 3a minus b equal 0. So we can say 3a equals 0. And a, oh, this should be minus b, guys. Minus b equals 0. So therefore, that implies b is equal to 0. And for this, a is also 0. So that's one option, a equals 0 and b equal 0. Another option would be b equal 3 and a equal 1. There are so many. Let's see now. 1, 3, 3, 3 minus 3 is 0. This could be 6, b could be 6, and that means a would be 2. So 1 times 3 times 2, 6 minus 6 times 1. And the list goes on and on and on. All right, let's look at number 4. What number 4 have to offer us? How you guys want to do this one? All right, let's go. Look out for my marathon now, guys. CSEC marathon coming up in, think about March, April. Exam is May, so we're gonna do it early. We're gonna do it topic by topic. So if you're weak on matrices, just check out that. My number is at the top. You guys definitely have to sign up early, all right? That's WhatsApp me, 876-549-2161, and that's it. All right, number 4 now, it says T is a matrix 2Q 0P P. State the determinant of T. All right, so basically we're just doing repetition. I think I need to rub off these though. You guys can always watch about the video. And please, guys, ensure say share with others. Mr. Bennett is not a selfish person, all right? Neither should you. All right, let's go now. Let's go. So we can actually come up right up here. So come work. All right, so it says if T, so let's write back T. So that's 2Q. And you have 0, P, and P. And it says find the determinant. We normally write DET for the determinant. And as we say, it's AD minus BC. Why this not look like A, guys? Yeah, man, it's A. All right, so A is 2Q times P minus 0 times P. That's it. So this will give us 2QP, PQ. I go put, no, guys, in maths, we normally put the letter in alphabetical order. Don't know if it's a written rule, but it just seems right. And 0 times that would be 0. So the determinant would be 2PQ. All right, so that's the determinant, 2PQ. All right, it goes on further to say if Q is a half and P is equal to 4, determine the inverse of T. So we're going to go back to the original one now. I think I've done this one on my channel before. I don't know what I haven't done on my channel. I've done so many past papers. All right, so let's go back to the original, which is this. But this time we're going to put in the values that we are given. All right, hit the like button, guys. Remember, you're encouraged to try. If you're not subscribed, please ensure that you do so now. So it says Q is equal to a half. So guess what? So it's P. Why may I put P? They gave us the values, so I'm supposed to put the values, not numbers, not the letters. All right, so 2, they said Q is a half, so it's times a half. We still have the 0 here, that doesn't change. And P is equal to 4, so we're gonna put 4 at this side and then another 4. And they're asked to find the inverse, all right? So this times this is gonna give us 1. So it's 1, 0, 4, 4. So this is what we have. To find it inverse, it's 1 over the determinant times the adjoint. All right, so I will walk you through the adjoint point. So 1 times 4, that's 4. 4 minus 0 times 4 is 0. So this determinant is actually 1 times 4 and minus 0 times 4, which I can work out to 0. I just want to show you guys a little step there. So in the end, you're going to get 4 minus 0. So for the determinant, it's 1 over 4. And then now, this is the adjoint. I'm going to show you the rule of the adjoint. So it's in the form A, B, C, D, right? So this is what the adjoint is. You're going to swap A and D. So where A is going to become D, and where D is become A. And then we change the sign of D. So it will be minus B minus C. Check out my earlier videos. I've done several videos on how to find it. All right. So let's go. 4 go up there. So now 1 go there. So we can't change Z to 0 to negative 0. All right. But this would be negative 4. So this would be our inverse. I would love to see how much marks for this. So the inverse of that would be 4, 0, negative 4, and 1. All right. All right. It says now, if T is a singular and P not equal to Q, state a pair of values. State a pair of values of P and Q. All right. So we're going to try and do that one now. Right away. Sorry. So I think I need to erase all of these. Please look clean. So it said P cannot be equal to Q. So it has to be 2 different values. All right. So what was the original thing that they gave us? It was 2Q 0 P and P. All right. So it would be 2PQ. Work on that already. I forgot, 2PQ equal to 0. If T is a singular matrix, state a pair of values of P and Q. P not equal to Q, state a pair of values for P and Q. All right, so it will be 2PQ. All right, so for this, guys, I'm thinking Q equals 0. Once you have Q equals 0, I think P can be anything. So say P of 5, right? So that'll be 2 times 5 times 0. I think any number can work. I'm not sure what CSEC try to say. Yes, so 2, 5, 10, 0 times that. Once one of them is 0, right? The product, because they have the product. So it can work for all of them. Once one of them is 0, either P or 0 or Q. All right, let's look at number 5. I think this is the last one, not sure. All right, so it says if R is a matrix, 3R1 S2, state in terms of S and R the determinant of R. All right, so it's the same thing, it's just repetition. So we know that determinant is AD, so it's 3. We'll label this. So it's A, B, C, D. So that's it. 3R times 2S minus 1 times S. Let me fix the S because I don't want people think so 35. So this will give us 6, 326 RS minus S. So that would be the determinant, 6R minus S, all right? All right, it says if R is equal to 1/3 and S is equal to 4, determine the inverse. This again. All right, so guys, so it's 3. Guys, why different type of question? It's different years, so don't worry about it. So 1 is not go here, so and then you have S of 4, so that'll be 4. And then that'll be 2 times 4, which is 8. So in the end, we'll get 1 here, so 1 here, so 4 and 8. So the determinant, the inverse rather, would be 1 times 8, so that 1 over 8. And then 1 times 4, so that's a quarter again. 8 go up here, so 1 go there, so. Remember the rule, this change to negative, this change to -4. So this would be our answer. All right. So that would be our final one. Guys, please ensure that you like the video. This is an explanation. Well on there, guys. Well on the C. There's a C to it. It says take the pair of values of R and S, not including 0, which make the matrix R a singular matrix. All right, so clear off this. So we're gonna use the determinant. Why them here so hard? Clear off a choke thing. All right, so let's go now. So it says state the values. State a pair of values of R and S, not including 0, which made the matrix R a singular matrix. All right, so we could go back from the determinant, right, which is this. So we add the determinant, so that was what, 6RS. Remember, it's S now, minus S, all right, and that must equal to 0. So we're going to factorize S common, so we have to take out the S. We're going to leave 6R, S into itself, 1. But remember, they say we can't use S equals 0. And none of them need. So we use this part, which is 6R minus 1 equals 0. So R is that equal to 1 over 6. So that's one of the solution. So we need to find out when R is 1 over 6, what does the value of S should be. All right, so 1 over 6. So that's 3 times 1 over 6. We're using these values now. The original value, 1. S, we don't know what is S, but we know so this is our 2S. So we don't know the value of S, right? This is a bit confusing. So this work out to what? A half. 3 into that, a half. So it's a half. And then this is gonna be 1. I think I need more space. And then this would be S, and this would be 2S. And all of that must equal to 0. So let's do it now. So it's gonna be half 2S, multiply minus S equals 0. So this is the work out to 1S, half into that left, S minus S. I think I did something wrong here, so you know. Yeah, this was the original, which is 2S. So that'll be 3R. So that's a 1, 6. When a 1, 6, they work out to half. Half time this is 1. So S a 1. So S can be R or 1, 6. S equal to 1. I don't have the space to work out everything right now. I'm going to start my next class. Yeah. So if R are that, so S is a bit 1. All right. So look, boom, you put this here. So 1, 6 into that, leave a half times 2 that give 1. And then S a 1, so that's a 1 times 1, that is 0. So S equal 1 and that equal. Oh guys, see one here you guys can do? Number 6. It says find the values of x for which the matrix P equal 3x, 4, 6x, brackets 6xx is a singular matrix. So notice it's a value, so it's more than 1. All right, I will have a part 2 for this. So guys, ensure that you like the video. This is Ronax Minute. I'm out, no doubt. See you guys in another video.